So be attentive, children. As you can make out, we are discussing some of the questions related to chapter solutions, and I've already done this in my last video. So I'm beginning with this question 2. So I would like to read it out. 0.5 grams KCl was dissolved in 100 grams of water, and the solution shows depression in freezing point equals to 0.24 Kelvin. Calculate the percentage ionization of the salt Kf, a constant given here 1.86 Kelvin kg per mole. So as you can make out, this is what? KCl, an electrovalent salt. So obviously it will go for dissociation, and this is degree of dissociation. The formula is I minus 1 upon n minus 1. So let's see first of all what we have to find out. N, since it is a solid KClS, in presence of water it changes into K plus and Cl minus. So N is equals to, that is what, ions formed after dissociation. Now we shall come back here. This is a regular formula for the colligative property, that is depression in freezing point. But since the salt is what? The salt is electrolyte here, that will change into ion. That's why we have to put this Van 't Hoff factor I here. And now this is a modified formula of the depression in freezing point colligative property. Now delta TF already given here, 0.24 Kelvin given. So I have written here 0.24. I we have to find out 1000. Kf is what? Kf is given in the numerical. It's a constant 1.86. Small w is 0.5 grams here. And m is the molecular mass of KCl, which comes to be K39 Cl 35.5 into 100. It is capital W. What is 100? Dissolved in 100 grams of water. So finally I am getting the numeral for value for I, that is coming 1.92. Putting this in the formula, see the asterisk here and there, putting this in the formula, this alpha is coming 1.92 minus 1 upon 2 minus 1, because n is 2, and the answer is 0.92 or 92%. Now you can see here I have written few multiple choice questions also. We'll discuss it later. Let's finish it, this one. This is the question. Read: 1 molar aqueous solution of trichloroacetic acid. There was less space, that's why I've written the formula. So this is trichloroacetic acid is heated to its boiling point. The solution has the boiling point 100.18 degrees Celsius. Determine the Van 't Hoff factor I. Kb is given as 0.512 Kelvin kg per mole. So you can see varied numericals are there in this chapter solution. Sometimes they can ask for molecular masses, sometimes they ask for degree of dissociation or association, and they can ask for I also in your board exams. So let's see. I have done, this is the first step, second step and the third step of the numerical. See, so first of all I have to find out delta TB. This is a question of the solution has boiling point. This is a question of the boiling point. So delta TB is going to be the difference between the two. One is the boiling point of the solution here, and then so TS is boiling point of the solution, and this is initially. After adding solute, it is the elevation of the boiling point, that is coming to be as 100.13. We have converted it into Kelvin. See, 373.18 minus 373, that is the boiling point of the water here. Okay, because it's an aqueous solution, make it out. It's an aqueous solution. So obviously this is going to be T naught is going to be 373 water, and it is solution on addition of this trichloroacetic acid. This becomes 373.18. So difference is 0.18 Kelvin. Now see here, the formula which I am using here, delta TB is equal to I. Again I, because it is I factor is involved here. Abnormal molecular mass is going to be Kbm. M is molality, which is given as what? 1 molar aqueous solution. So 0.18 equals I into Kb given here in the numerical, 0.512 into 1. Therefore, the value of I is coming this much. Now, one more thing which is not given in this numerical. Sometimes they ask, determine the status of the solute in the solution. So, what is going to be your answer? It's not given in the question, but it should have been given over here. So, what is your answer? I is less than 1. So, obviously, what does it mean? That it is undergoing association. Clear, children? Now, let's have this multiple choice question. It's a very common thing in your exam, your competitions. So, let's see. The lowest freezing point of 0.1 m aqueous solution is of. 4 options given here: NaCl, urea, K2SO4 and glucose. So just think for 30 seconds and the answer is going to be there with you. Think. Now see, let's see. NaCl, how many particle it is going to dissociate? 2 particle. Okay. Urea, it remains 1. It neither associates nor dissociates, so urea remains 1. This K2SO4, K2 plus 2 particle here and 1. So overall they are going to have 3 particles and this is 1 remains 1. Neither associate nor dissociate. And what is that? Lowest freezing point. That is what? Depression in freezing point, which is directly proportional to lowering of the vapor pressure. And this, how many particles are here? 3. Particles which are here are 3. So the answer is going to be this. This is the answer. Clear? Now let's see the second question. Which of the following salts would have the same value of Van 't Hoff factor as that of K3FeCN6? Now what is this K3FeCN6? It is potassium hexacyanidopherate. It's a coordinate compound which you are going to study in class 12 and we'll be studying it later. So now what happens here? When this coordinate compound it is being dissolved, it will convert into this ion K and this is remain as such. FeCN6 is going to be 1 particle. So in this, because I think that you do not know about this coordination. Some of you might be knowing that. So that's why I am explaining what will happen here. In this case, we are going to get 3 plus 1, 4 particles on dissolution, and that you have to check out here. Let's see. NaCl 2 particle, Na2SO4 3 particle, 2 plus 1 and 2 valency is 1, Na2. So this is 2 particle plus 1 3 and it is again 2. How many here? Aluminum valency 3. This is 3 part. NO3. So these are going to dissociate into 4 particles here. Al, that is aluminum nitrate. It's going to have 4 particles and this one also is going to have 4 particles. So the answer is going to be here equal number of particles. So the answer is going to be here as this. This is your answer. Clear? Now let's see the third one here. The osmotic pressure of equimolar solutions of glucose, sodium chloride and barium chloride will be in order. Clear? Osmotic pressure, remember, pi is equal to CRT. So it is going to be of equimolar, means their concentrations are same. Equimolar hai na? Pi is equal to CRT. So equimolar, C is same and RT, both are constants here. R is the solution constant and T is the constant temperature. So an equimolar. So still there is some difference in the solute, which is what? Glucose remains as such, sodium chloride and barium chloride. How many particles here? 2. Barium chloride, BaCl2. This, how many particles? 3. So just consider what will be the answer here. Is this one is going to be the answer? BaCl2, glucose and NaCl? No, because glucose remains 1. Is this one is going to be the answer? Because osmotic pressure of will be in the order. So order is not going to be followed by B, C and D. Check. check in for 30 seconds. You just check it out and tell me the answer. What is going to be the answer? Or you find it out on your own. I am showing you here. This is going to be as this one is the answer. A is the answer here. This is the answer. So in this manner you have to solve these questions, and for that your concept should be clear, and that's all for today.